Good morning, mathematicians. Today we'll be starting Unit 8 by going back to Lesson 712A, Multiplying Fractions by Whole Numbers. Our objective for today is to apply and extend previous understandings of multiplication to multiply a fraction by a whole number. Let's get started with our warm-up. On the board are the first three multiples in a set. I would like you to write down the next three multiples that come next. I'll say the first three, and you can say the next three that follow. 82, 84, 86, 56, 60, 64, 18, 27, 36, 'Go ahead and erase your boards and get started on the next set. Again, I'll say the first three, and you can say the next three that follow. 70, 140, 210, 600, 1,200, 1,800, 125, 250, 375, 'Go ahead and erase your boards and get started on the last set. You'll notice that this set is fractions, but we can do the same thing. And finally, I'll say the first three, and you can say the next three that follow. 1/10, 2/10, 3/10, 1/4, 2/4, 3/4, 'Go ahead and erase your boards and set them to the side. Let's take a look at this problem, 3 times 1/2. You can see we have a number line to the side. I want you to think about and turn and talk with your partner about how you could use the number line and your understanding of multiples to help you solve this problem. One way we can do that is to visualize jumps or hops on the number line starting at 0. The fraction here tells us the size of the jump, and the whole number here tells us the number of jumps. So we know that we have to take 3 jumps that are each 1/2 of a unit long. So I'm going to start at 0 and do 1, 2, 3 jumps, and that leaves me at 3/2. So 3 times 1/2 equals 3/2, or 1 1/2. Let's take a look at problem 1 on page 217A. The directions say, for problems 1 through 3, fill in the blanks to complete an equation describing the number line. So here's the start of our equation. 5 times blank equals blank. We know that the 5 represents the number of jumps, so we're missing the size of the jumps. We can look up at our number line to see that each jump is 1/8 long. So I'm going to write in my 1/8, and then I have to look at where we end up. And we end up at 5/8. So we know that 1/8 times 5 equals 5/8. Let's look at this next one. This is actually, we're jumping down to number 4 on page 217A. This one's a little bit different. It gives us the first two numbers in the equation, 2 times 1/4. And we need to find the answer by using the number line. So we know that our 2 is our number of jumps, and our 1/4 is how long those jumps are going to be. So I need to do 2 jumps, 1, 2, that are each a fourth long. We can see here that I ended at 2/4, so 2 times 1/4 equals 2/4. fourths. When multiplying fractions, there is an algorithm or a rule that you can follow to help you figure out the answer. And that is n, which stands for any number, any whole number, times a over b, which stands for any fraction, equals that whole number times your numerator over that same denominator. Let's try that for number 1. It says 5 times 1/8 equals. I can do my number times my numerator, 5 times 1, and I know that equals 5. And we keep our denominator the same, 5/8. And we can see that 5/8 is the same as what I had here. Now let's try that for our next one that we had on there, number 4. And our equation was 2 times 1/4. Let's check that one with our algorithm. 2 times 1/4 equals. I can do my 2 times my numerator, so 2 times 1, and I know that equals 2. And we keep our denominator the same, so we keep that as 4. And again, that matches, so I know I did it correctly. Now let's take a look at the two examples on page 217b. With your partner, I want you to look for any similarities and differences you see between the two equations modeled on the number lines. So we're looking here at 6 times 1/5 equals 6/5, and 3 times 2/5 equals 6/5. Go ahead and talk with your partner now. What are some similarities and differences that you have noticed? You may have noticed that both equations involve multiplication of a fraction by a whole number. You may have also noticed that both equations have the same product and end at the same spot on the number line. You might have also noticed a difference in the factors. However, 1/2 is a multiple of 1/5, and 6 is a multiple of 3. You also might have noticed that it takes more jumps to get to 6/5 when counting by 1/5 than it does when counting by 2/5. Let's look together at problem 1 on page 217b. Again, we all notice that we end at the same spot on the number line, so we should have the same product. In the first one, I notice that my fraction that I'm counting by is 1/4. And I took 1, 2, 3, 4, 5, 6 jumps. So my whole number is 6 times my fraction 1/4. And on the bottom, I notice that my jumps are 3/4 long, and I'm only taking 2 jumps. So my whole number is 2 times my fraction 3/4. Now I can count to see what my answer would be. And I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. So 6 times 1/4 equals 6/4. The bottom 2 should also be 6/4 because we're counting by fourths and it's ending at the same spot. So I'm going to double check that using my algorithm. I know that 2 times 3 equals 6, so that's going to be my numerator, and my denominator of 4 stays the same. So they both equal 6/4. Now let's take a look at page 217d, which will be solving number stories using multiplication of whole numbers times fractions. It says, Suma and her sister Pooja are making 12 blueberry wheat muffins for breakfast. The recipe lists the following ingredients: 1 cup flour, 1/2 cup whole wheat flour, 2 teaspoons baking powder, 3/4 cup blueberries, 1/4 teaspoon salt, 1 egg, 1/2 cup skim milk, 2/3 cup honey, 1/4 cup cooking oil, 3/8 teaspoon cinnamon. Use the list of recipe ingredients to help you solve the number stories below. For each problem, write an equation to show what you did. Number 1 says, the sisters decided to double the recipe. So right now I'm thinking that it is telling me what I need to do or what I need to multiply by. And I know that doubling something means you're multiplying by 2. So I'm going to write that there as a reminder to myself. Now part A says, how many cups of whole wheat flour do they need now that I'm doubling it? So we would need to look back at the recipe to figure this out. Who can help me out with this problem? Right, we know that we're multiplying times 2, so we're going to have 2 times, and we have to look back at whole wheat flour. And we can see that that was already 1/2 of a cup, so 2 times 1/2 equals, and you're correct if you said 2/2 or 1 cup. Part B says, how many cups of blueberries do they need now? Who can help me out with this one? Yes, again we're doubling the recipe, so we're doing 2 times, and our blueberries were 3/4 of a cup. And using our algorithm to figure that out, we could do 2 times 3, which is 6, over our denominator 4. So 6/4 cup, or 1 1/2 cups. And finally, part C says, how many cups of honey do they need now? Who can help me out with this final problem? We can see that honey was 2/3 cups before, and we know that we have to double our recipe, so we're multiplying it by 2. And we know that we can see that equals 4/3. So our answer is 4/3 or 1 1/3 cups. Today, as you go off to work on your own, looking at our learning journey, we know that we already completed the mental math. We still need to complete the remainder of the journal pages, 217A to 217E. And we are going to cross out Math Boxes 8.1 for today. When you get done, for Activity B, you're going to go to Blend Space Practice A, and for Activity C, you're going to first read page 58 in the student reference book, then do Math Masters, page 242C to 242D, and then if you have time, go to Blend Space Practice B. Make it a great day.